Unit 3, Video Lecture 5, Orbital Diagrams and Electron Configurations, Part 1. Before we begin, let's review a couple things. Which principle tells us that no two electrons can have the same set of 4 quantum numbers? This would have been the Pauli exclusion principle. Remember, the Aufbau principle tells us that we fill low energy to high energy. Which letter is pointing to the sublevel? This would be B. P is our sublevel in addition to S, D, and F. A is pointing to our energy level, and C is pointing to the number of electrons that are present. An orbital diagram is a visual representation of an electron configuration. It's a model of an electron. We're going to make use of our Pauli exclusion principles and our Aufbau principles to do it. We're going to use arrows to represent our electrons. We need another rule in addition to Pauli's exclusion principle and the Aufbau principle. We need Hund's rule. Hund's rule tells us that in orbitals of equal energy, we have to place a single electron before we make a pair. It also tells us that our single electrons must be spinning the same way. So let's practice. Let's look at lithium. The atomic number of lithium is 3. This means that the total number of electrons in lithium is 3. When we look at our orbital diagram, we have 1, our energy level, 2, and 3. So this orbital diagram only shows 3 energy levels. We have our sublevels, S and P, and we have those orbitals that we've talked about before. Remember that the S sublevel has 1 orbital. That's why there's only 1 box here. The P sublevel has 3 orbitals. 1, 2, 3, 1, 2, 3. So we'll place the first electron in 1s, because according to Aufbau, we need to fill the lowest energy sublevels first. So we use an upwards arrow. And we'll add the second electron that we need to place in 1s. Remember that an orbital can only hold 2 electrons, so this orbital and energy level and sublevel are all full. Therefore, we'll move to the next higher one, the 2s. We place 1 electron in 2s. We've placed all 3 electrons, 1, 2, 3. So therefore, we're done. Our electron configuration then is 1s2, because in the first energy level, in the s sublevel, we have 2 electrons. 2s1, the 1 electron in the 2s sublevel. Let's look at carbon. Carbon's atomic number is 6, and it has 6 total electrons. So if we begin placing our electrons, we'll put 2 in 1s, 1 up arrow, 1 down arrow. We'll put 2 in 2s, 1 up and 1 down. And we still have 2 electrons left to place. They're going to go in the 2p sublevel. So we place our first one. And now it's the first time we're going to look at Hund's rule. Remember that Hund's rule says to fill orbitals singly. So instead of putting the downward arrow here, we're going to put a second up arrow in the second orbital. Therefore, our electron configuration is 1s2, 2s2, 2p2, because there are 2 electrons in the 2p sublevel. Let's look at oxygen. Oxygen's atomic number is 8, and therefore we have 8 total electrons. If we begin placing them, we'll put 1 up and 1 down in the 1s. We'll put 1 up and 1 down in 2s. So we've placed 4 electrons already. We still need 4 electrons. So in the 2p, we'll fill 1, 2, 3, 4. Therefore, our electron configuration is 1s2, 2s2, 2p4. 1, 2, 3, 4 electrons in the 2p sublevel. Let's practice with another element, nickel. Nickel's atomic number is 28, which means that it has 28 total electrons. So if we start placing, we can put 1 up and 1 down in 2s, 1 up and 1 down in 2s, 1 up, 1 up, 1 up, 1 down, 1 down, 1 down in 2p. At this point, we've placed 10 electrons. We still need to find a home for 14 electrons. So we go 1 up and 1 down in 3s, 1 up, 1 up, 1 up, 1 down, 1 down, 1 down in 3p. At this point, we've placed 18 electrons, meaning that we still need to find a home for 10. So we 1 up, 1 down in 4s, bringing us to 20 electrons. So we'll fill the 3d sublevel with 8. So following Hund's rule, 1 up, 1 up, 1, 1 up, 1 up. Now that all 6 orbitals have a single electron, we can go back to double up. 1 down, 1 down, 1 down. This gives us an electron configuration for nickel of 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. Please pause the video and attempt the orbital diagram for calcium. This should be the correct diagram for calcium. Its electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Now, let's take a look at an orbital diagram for barium. There's a mistake here, and let's see if we can find it. The mistake occurs in the 2s sublevel. If you notice, we have 2 arrows pointing upwards. That means that both of those arrows have the same 4 set of quantum numbers. That violates Pauli's exclusion principle. Let's look at another one. Do you see the problem with this one? Let's look at the 4d energy level. Do you see it now? In the first orbital of the 4D sublevel, we have 2 electrons occupying a single orbital before each orbital has an electron. This violates Hund's rule. One more. Again, we see the problem in the 2s sublevel. It is not completely filled. What principle does this violate? The Aufbau principle. If we were to fix this, we would take one of the electrons from up here and correctly put it down there.